Welcome to Tech with Kaushik. This is part 5 of our complete practice question series for the AZ-104 Microsoft Azure Administrator exam. Test your knowledge with exam-focused questions covering key Azure administration concepts. Choose your answer before the timer ends, then review the correct answer, clear explanation, and practical exam tip. Let us begin part 5. We will now analyze question number 168. This one tests your understanding of Azure Monitor logs. Review the scenario carefully. You host a public-facing API on a Windows-based Azure app service named Customer API. Customers report intermittent HTTP 500 responses. Developers need the raw HTTP request records, including status codes, request URLs, and client details. Which app service logging capability should you enable? Compare the following options. Option A is Service Health Alerts. Option B is Web Server Logging. Option C is an Azure Monitor Workbook. Option D is Application Logging. In this case, select Option B, Web Server Logging. The reasoning is as follows. Web server logging records raw HTTP requests in the W3C extended format for Windows App Service apps, including request paths and HTTP status information needed to investigate 500 responses. The other choices do not satisfy the requirement because A. Service Health Alerts report Azure Service incidents, not individual HTTP requests. C. A workbook visualizes existing telemetry but does not create the HTTP request records. D. Application logging captures messages emitted by application code rather than the complete web server request log. Remember this distinction for the exam. Use web server logs for HTTP request and status code details. Use application logs for messages written by the application. Let us work through question number 169. Begin by examining the scenario. Your Azure subscription contains a resource group named AppDev. All resources in this group were provisioned using ARM templates. You need to verify the exact date and time a specific resource deployment completed. You attempt to find this information by navigating to the subscriptions blade, selecting the subscription, and clicking Programmatic Deployment. Does this meet the goal? Choose from the following options. Choice A, yes. Choice B, no. The appropriate choice is option B, no. The key reason is the correct location to view historical ARM template deployments, including dates, times, and execution status, is the deployments blade under the specific resource group, AppDev, not the subscriptions blade. The alternatives can be eliminated because A. This action does not navigate to the correct blade for viewing resource group level deployment history. Keep this examination point in mind. To review the history, success status, and timestamps of ARM template executions, check the deployments blade of the target resource group. Proceed to question number 170. This question moves us into action groups. You monitor an Azure virtual machine named DB Server 1. An existing Azure Automation Runbook can create incidents in your on-premises service management system through a hybrid runbook worker. You create a metric alert that fires when available memory falls below 5%. Which action should you add to the alerts action group? Option A, Automation Runbook. Option B, Email Azure Resource Manager role. Option C, Service Health Notification. Option D, Secure Webhook without a receiving endpoint. The best answer is option A, Automation Runbook. Azure Monitor action groups can invoke an Azure Automation Runbook when an alert fires. The hybrid runbook worker allows the runbook to reach the on-premises service management system and create the incident. The remaining options are incorrect because B, emailing an Azure role only sends a notification and does not create an incident. C, Service Health Notifications concern Azure service events and are not an action that performs this custom workflow. D, a webhook requires a valid receiving endpoint. Without one, no ticketing action occurs. A useful examination rule is this. Use an action group automation runbook action when an Azure Monitor alert must trigger an operational script. Question number 171. Scenario. Your Microsoft Entra tenant has the required licenses for Self-Service Password Reset, SSPR. You must enable SSPR only for members of a security group named SSPR Pilot. Which configuration should you apply in the Microsoft Entra Admin Center? Review the options. Choice A. In Password Reset Properties, set Self-Service Password Reset enabled to selected and choose SSPR Pilot. Choice B. In Device Settings, add SSPR Pilot as additional local administrators. Choice C. In User Settings, allow users to register applications. Choice D. In Conditional Access, exclude SSPR Pilot from all policies. The required response is option A. In Password Reset Properties, set Self-Service Password Reset enabled to selected and choose SSPR Pilot. This is correct because the SSPR Properties page supports enabling password reset for selected users by choosing one Microsoft Entra group. This limits SSPR enrollment and use to the pilot group. The incorrect choices fail for the following reasons. B. Device Settings control device administration, not password reset scope. C. Application registration permissions are unrelated to SSPR. D. Conditional access exclusions do not enable self-service password reset. The key takeaway is use the selected scope in SSPR Properties to pilot self-service password reset with one Microsoft Entra group. The next item is question number 172. We are moving to ARM templates. Review the situation. You are preparing to deploy an ARM template named webdeployment.json that defines 15 Azure web apps. You need to ensure the necessary prerequisite resource exists before executing the template. To minimize costs, all 15 web apps should share the same compute resources. What must be identified or created prior to deploying the web apps? The options are: Choice A, 15 individual app service plans. Choice B, 1 Azure Application Gateway. Choice C, 1 App Service Plan. Choice D, 1 Azure Traffic Manager Profile. The correct answer is option C, 1 App Service Plan. Here is the technical justification. Azure App Services, web apps, require an underlying compute context to run, which is the app service plan. Multiple web apps can be hosted on a single app service plan to minimize costs, sharing the allocated CPU and memory. Now consider why the remaining options are unsuitable. A. Creating 15 individual app service plans would isolate the apps but maximize compute costs unnecessarily. B. An application gateway is a load balancer and not a prerequisite compute container for deploying web apps. D. Traffic Manager provides DNS-based routing. It does not replace the requirement for an app service plan. To minimize costs for multiple Azure web apps, deploy them into a single, shared app service plan. Now consider question number 173. Consider this scenario. An Azure virtual machine named AppVM runs a critical line of business application. The VM currently uses the standard _D4S_V3 size and has a single managed disk. You are tasked with applying several updates to AppVM. Which of the following planned actions will require the virtual machine to restart, causing application downtime? Available choices. Option A, changing the VM size to standard _D8S_V3. Option B, adding a new 1 TB managed data disk. Option C, enabling desired state configuration, DSC. Option D, installing the custom script extension. The appropriate choice is option A, changing the VM size to standard _D8S_V3. The requirement is satisfied because changing the size of a virtual machine involves reallocating the VM to new hardware capacity. This process requires the virtual machine to be gracefully shut down, restarted, and temporarily taken offline, causing application downtime. B. Azure allows you to attach new managed data disks dynamically while the VM is running without requiring a reboot. C. Enabling Azure extensions like DSC generally installs a background agent on the running VM without requiring a reboot of the host OS. D. The custom script extension executes scripts inside the running OS. It does not natively trigger a VM reboot unless your custom script forces one. Exam tip. Resizing a virtual machine in Azure requires the VM to be restarted, resulting in temporary downtime. Let us examine question number 174. Consider the following scenario. Your Azure subscription contains 15 virtual networks across multiple resource groups. Security compliance requires that any newly created network security group, NSG, must automatically contain a rule blocking TCP port 3389. You attempt to meet this requirement by unregistering the Microsoft Classic Network provider from the resource provider's blade. Does this meet the goal? Review each available choice. Choice A, yes. Choice B, no. In this case, select option B, no. The reasoning is as follows. Unregistering the Microsoft Classic Network provider only prevents the deployment of legacy, ASM, virtual networks. It has no effect on creating modern ARM-based network security groups or enforcing port blocking rules. The other choices do not satisfy the requirement because A, the action does not fulfill the technical requirement. Remember this distinction for the exam. To enforce configurations, like denying specific open ports on NSGS, across an entire subscription, use Azure policy. Proceed to question number 175. You must rapidly deploy 5 stateless virtual machines. Every instance must use one shared VM model, remain identical, and be managed as scale-set-specific instances rather than as independent standard Azure virtual machines. Which deployment should you use? Review the options. Option A. A virtual machine scale set with uniform orchestration. Option B. 5 standalone virtual machines in an availability set. Option C. 5 standalone virtual machines distributed across zones. Option D. A virtual machine scale set with flexible orchestration. The best answer is option A. A virtual machine scale set with uniform orchestration. The key reason is uniform orchestration uses a single scale set VM profile and creates identical scale set specific VM instances. It is designed for workloads that are managed and scaled as one homogeneous unit. The alternatives can be eliminated because B, standalone virtual machines do not use one scale set model or provide group scaling. C, availability zones improve fault isolation but do not create a single homogeneous management unit. D, flexible orchestration manages standard Azure virtual machines and is intended when individual VM control and mixed configurations are required. Keep this examination point in mind. Uniform uses one VM profile for identical scale set instances. Flexible manages standard Azure virtual machines with greater per instance control. Review question number 176. Carefully. Let us first review the situation. Your Azure subscription contains 15 virtual networks across multiple resource groups. Security compliance requires that any newly created network security group, NSG, must automatically contain a rule-blocking TCP port 3389. You attempt to meet this requirement by creating a read-only resource lock and assigning it to the subscription. Does this meet the goal? Now examine the possible answers. Option A is yes. Option B is no. The required response is option B, no. A resource lock, either read-only or cannot delete, prevents modification or deletion of resources. It cannot inspect the configuration payload, like checking if port 3389 is open, of an NSG during creation. Azure policy is required for this enforcement. The remaining options are incorrect because A, the action does not fulfill the technical requirement. A useful examination rule is this. Use Azure policy to enforce configuration standards inside a resource payload, for example, ports, sizes. Use resource locks to prevent deletion or modification of the resource itself. Now consider question number 177. Next, we enter the topic of VNet peering. Scenario. Your Azure environment contains VNet NE in North Europe and VNet WE in West Europe. The virtual networks have non-overlapping address spaces. Resources in both virtual networks must communicate privately over the Microsoft backbone with low latency, and you do not want to deploy VPN gateways. Which configuration should you implement? Choice A. Global Virtual Network peering between VNet NE and VNet WE. Choice B. A site-to-site VPN connection between the virtual networks. Choice C. An Azure application gateway in each virtual network. Choice D. An on-premises data gateway in each region. The correct answer is option A. Global Virtual Network peering between VNet NE and VNet WE. This is correct because global virtual network peering connects virtual networks in different Azure regions. Traffic uses private IP addresses and remains on the Microsoft backbone without requiring VPN gateways. The incorrect choices fail for the following reasons. B. A VNet to VNet VPN requires gateways, adds administrative overhead, and is unnecessary for non-overlapping Azure VNets. C. Application gateway load balances inbound HTTPS traffic and does not provide general VNet connectivity. D. An on-premises data gateway is an application data connector, not an Azure network routing service. The key takeaway is use global VNet peering for private connectivity between Azure VNets in different regions when their address spaces do not overlap. Question number 178. Review the situation. Your on-premises environment connects to an Azure virtual network named VNet Core using a site-to-site VPN. Remote developers use a point-to-site (P2S) VPN client on their Windows 10 machines to connect to VNet Core. You create a new virtual network named VNet Data and successfully peer it with VNet Core. You confirm that servers in the on-premises environment can reach VNet Data. However, the remote developers using the P2S VPN complain they cannot access resources in VNet Data. How can you restore connectivity for the remote developers? The options are: Option A. Download and reinstall the VPN client configuration package on the developers' computers. Option B. Enable BGP on the virtual network gateway in VNet Core. Option C. Select Allow Gateway Transit on the peering settings of VNet Core. Option D. Select Allow Gateway Transit on the peering settings of VNet Data. The appropriate choice is option A. Download and reinstall the VPN client configuration package on the developers' computers. Here is the technical justification. Point-to-site (P2S) VPN clients maintain a local routing table on the host OS. When a new VNet is peered and routes are updated on the Azure VPN gateway, the client configuration packages must be re-downloaded and reinstalled on the client laptops to push the new network routes to them. Now consider why the remaining options are unsuitable. B. BGP manages dynamic routing for site-to-site connections, not individual P2S client route tables. C. Allow Gateway Transit allows the spoke to use the hub's gateway, it doesn't automatically update existing P2S client devices. D. Allow Gateway Transit on the spoke, VNet Data, would imply the spoke has its own gateway, which is incorrect. When VNet peering is added to a VNet with an active point-to-site VPN, remote clients must re-download the VPN profile to receive the new routing rules. The next item is question number 179. The focus now shifts to Connection Monitor. Consider this scenario. You manage an application spread across two virtual networks. WebVM is located in VNet frontend, and DBVM is located in VNet backend. Users complain of sluggish performance. You suspect network latency between the two virtual machines is the root cause. You need to continuously measure the average round-trip time, RTT, of network packets traveling from WebVM to DBVM. Which Azure Network Watcher tool is designed for this requirement? Available choices. Choice A. IP Flow Verify. Choice B, connection troubleshoot. Choice C, connection monitor. Choice D, NSG flow logs. The correct answer is option C, connection monitor. The requirement is satisfied because Connection Monitor, a feature of Azure Network Watcher, provides unified end-to-end connection monitoring. It allows you to track network latency, round-trip time or RTT, and packet loss between Azure virtual machines, offering historical tracking and alerts. A. IP flow verify checks if a specific packet is allowed or denied by NSG rules. It does not measure latency. B. Connection troubleshoot performs a one-time diagnostic check for connectivity issues but does not continuously track average RTT. D. NSG flow logs capture 5-tuple packet data, source, destination, port, passing through an NSG, not real-time latency measurements. Exam tip. Use Network Watcher Connection Monitor to track average round-trip time, latency, and detect network performance degradation between virtual machines. Proceed to question number 180. Review the situation. You deploy 2 third-party network virtual appliances, NVAs, into a subnet named NVA subnet. These appliances inspect traffic flowing between a DMZ subnet and an app subnet. You need to configure an Azure load balancer to distribute traffic to the NVAs. The requirements are, the NVAs must operate in an active-active cluster with automatic failover. The load balancer must handle traffic destined for multiple different IP addresses on the app subnet. Which 3 configuration steps are required to implement the load balancer? You need to identify 3 correct options. Available choices. Choice A. Add load balancing rules with high availability ports enabled and floating IP enabled. Choice B. Deploy a standard SKU load balancer. Choice C. Add load balancing rules with high availability ports enabled and floating IP disabled. Choice D. Add multiple front-end IP configurations, 1 backend pool, and a health probe. Choice E. Deploy a basic SKU load balancer. Choice F. Add a front-end IP configuration, 2 separate backend pools, and a health probe. Select option A. Add load balancing rules with high availability ports enabled and floating IP enabled. Option B. Deploy a standard SKU load balancer. And option D. Add multiple front-end IP configurations, 1 backend pool, and a health probe. The reasoning is as follows. High availability ports on a standard internal load balancer can distribute all ports and protocols across the active-active NVA backend pool. Multiple destination IP addresses require multiple front-end IP configurations and corresponding high availability ports rules. Floating IP must be enabled for those rules, and a health probe removes an unhealthy NVA from rotation. The other choices do not satisfy the requirement because C. Floating IP must be enabled so the backend NVAs can parse the varied destination IP addresses transparently. E. Basic load balancers do not support the high availability ports feature. F. 2 backend pools would separate the NVAs instead of distributing each frontend's traffic across the same active-active cluster. Remember this distinction for the exam. Network virtual appliances, NVAs, require a standard load balancer with high availability ports enabled to inspect traffic across all ports dynamically. Enable floating IP, DSR, so the NVA retains the original packet IP. We will now analyze question number 181. The focus now shifts to Recovery Services Vault. Let us first review the situation. You have migrated an on-premises virtual machine named Server SQL to Azure. You are tasked with implementing a daily backup schedule for the virtual machine to protect against data loss. What is the first resource you must provision in Azure to support this backup solution? Now examine the possible answers. Option A is an Azure backup server. Option B is a backup policy. Option C is a Recovery Services Vault. Option D is a recovery plan. In this case, select option C. A Recovery Services Vault. The key reason is to utilize Azure Backup for an Azure virtual machine. The administrative prerequisite is to create a Recovery Services Vault. The vault securely stores the backup data and configuration policies. The alternatives can be eliminated because A. Azure Backup Server, MABS, is used for protecting complex on-premises workloads, not standard Azure virtual machines. B. A backup policy dictates the schedule and retention, but it must be created inside or applied to an existing vault. D. A recovery plan is a feature of Azure Site Recovery used for orchestrating disaster recovery failovers, not standard backups. Keep this examination point in mind. The foundational resource for backing up Azure virtual machines using Azure Backup is the Recovery Services Vault. The next item is question number 182. Scenario. You have 500 gigabytes of architectural blueprint files stored on a local file server. You need to migrate these files into an Azure Blob Storage container. You require a graphical user interface tool to manage the upload process and verify the contents. Which tool should you use? Review the options. Option A. Azure Storage Explorer. Option B. The Azure Import-Export Service. Option C. File Explorer with a mapped drive using a SAS token. Option D. File Explorer with a mapped drive using an access key. The best answer is option A. Azure Storage Explorer. Azure Storage Explorer is a free, standalone graphical desktop application developed by Microsoft that allows you to visually manage, upload, and verify files across Azure storage accounts, including blobs and file shares. The remaining options are incorrect because B. The import-export service involves shipping physical hard drives to an Azure data center, which is excessive and unnecessary for 500 gigabytes of data. C. File Explorer cannot map a drive to a blob container using a SAS token. It maps to Azure file shares using SMB and access keys. D. File Explorer maps drives to SMB Azure file shares, not blob storage containers. A useful examination rule is this. When you require a graphical user interface, GUI, to manage or migrate data to Azure Storage, use Azure Storage Explorer. The next key item is question number 183. This question moves us into app service networking. The central scenario is as follows. You host a PHP web application on an Azure app service named Customer Portal. The application needs to query a PostgreSQL database hosted on an Azure virtual machine named DBNode. The virtual machine resides in a virtual network named VNet Data. The database server does not have a public IP address. How can you provide Customer Portal access to the database? The relevant choices are as follows. Option A. Deploy an internal load balancer in VNet Data. Option B. Configure VNet integration for Customer Portal to connect it to VNet Data. Option C. Establish virtual network peering from VNet Data to a new virtual network. Option D. Deploy an Azure Application Gateway in VNet Data. The required response is option B. Configure VNet integration for Customer Portal to connect it to VNet Data. This is correct because VNet integration gives an app service the ability to send outbound traffic directly into an Azure virtual network. By integrating Customer Portal with VNet Data, the web app can route traffic to the private IP address of the database VM. The incorrect choices fail for the following reasons. A. An internal load balancer balances traffic among multiple virtual machines. It does not grant the external app service access to the VNet. C. Peering connects two VNets. An app service is a PaaS resource and must use VNet integration first before peering rules apply. D. Application Gateway handles incoming web traffic, not outbound traffic from an app service to a backend DB. The key takeaway is to allow an Azure app service to reach private resources inside a virtual network. Configure VNet integration. Now consider question number 184. You are writing an ARM template to deploy an Azure Virtual Machine scale set based on a Windows Server Data Center image. The scale set must automatically install the IIS web server role and specific application files on every new instance immediately after it is provisioned. Which two steps should you take to accomplish this? Choose the best two responses. Option A. Modify the extension profile section of the ARM template. Option B. Upload a configuration script, such as PowerShell, to an accessible location. Option C. Create a new virtual machine scale set directly from the Azure portal. Option D. Deploy an Azure automation account. Option E. Assign an Azure policy to the resource group. The choices that satisfy the requirement are Option A. Modify the extension profile section of the ARM template, and Option B. Upload a configuration script, such as PowerShell, to an accessible location. Here is the technical justification. To automate the installation of roles or software on VM scale set instances during provisioning, use the custom script extension. In an ARM template, you define this under the extension profile section. The extension requires the target script to be hosted in a reachable location, such as Azure Storage or GitHub. Now consider why the remaining options are unsuitable. C. Deploying from the portal manually does not automate the deployment via an ARM template as requested. D. Azure Automation is for ongoing configuration management, like update management or DSC, but custom script extension is the direct method for executing a script on provision via ARME. Azure policy governs resource compliance. It is not the primary tool for executing custom PowerShell app installations inside a VM. Use the custom script extension defined in the extension profile of an ARM template to run configuration scripts on new virtual machine scale set instances automatically. Question number 185. Consider this scenario. A virtual network named VNetDMZ contains a subnet named WebSubnet. 3 Azure virtual machines reside in this subnet and host public-facing HTTPS websites. Each VM has a public IP address. VNetDMZ is connected to your on-premises network via a site-to-site VPN. During an audit, you discover that the virtual machines are accessible via RDP, port 3389, from any IP address on the Internet. You must ensure RDP is strictly blocked from the Internet but remains accessible from the on-premises network. HTTPS traffic from the Internet must continue to work. What should you do? The options are: Choice A. Remove the public IP addresses from the virtual machines. Choice B. Modify the address space configuration of the subnet. Choice C. Create a deny rule for RDP traffic in the Network Security Group, NSG, linked to WebSubnet, and a higher priority allow rule for the on-premises prefix. Choice D. Modify the local network gateway address space to exclude the Internet. In this case, select Option C. Create a deny rule for RDP traffic in the Network Security Group, NSG, linked to WebSubnet, and a higher priority allow rule for the on-premises prefix. The requirement is satisfied because Network Security Groups, NSGs, evaluate rules by priority. By creating an explicit rule to allow RDP, port 3389, from the on-premises IP range at a higher priority, and a subsequent rule denying RDP from the Internet, or any, you securely restrict access while allowing web traffic, port 443, to remain unaffected. A. Removing the public IP addresses would break the requirement for the websites to be accessible from the Internet over HTTPS. B. Subnet address spaces define the internal IP range boundaries. They do not filter incoming traffic. D. The local network gateway defines the on-premises IP address space for VPN routing, not firewall security. Exam tip. Use Network Security Groups, NSGs, linked to a subnet to explicitly allow administration ports, like RDP-SSH, only from trusted on-premises IP ranges while denying them from the Internet. Let us work through question number 186. Treat this as a medium question. Consider the following scenario. You provision an Azure App Service web app named Marketing Site using the free app service plan tier. You want to deploy a major update to the application and test it without affecting live users. You attempt to create a deployment slot, but the option is grayed out in the Azure portal. What must you do first to enable the creation of a deployment slot? Choose from the following options. Choice A. Scale out the app service plan to add more instances. Choice B. Map a custom domain to Marketing Site. Choice C. Scale up the app service plan to the standard or premium tier. Choice D. Modify the application settings for the web app. The appropriate choice is option C. Scale up the app service plan to the standard or premium tier. The reasoning is as follows. Deployment slots are an advanced deployment feature. The free and basic tiers of Azure App Service plans do not support deployment slots. You must scale up the underlying compute hardware, app service plan, to the standard, premium, or isolated tier to unlock the feature. The other choices do not satisfy the requirement because A. Scaling out adds more VM instances to handle traffic. It does not change the tier or unlock new capabilities like deployment slots. B. Custom domains map URLs to the app. They have no relation to enabling deployment slots. D. Application settings define environment variables for the running code, not platform-level feature tiers. Remember this distinction for the exam. Deployment slots for Azure App Services are only available on the standard, premium, and isolated app service plan tiers. Let us focus on question number 187. This scenario establishes the key requirement. You are migrating an internally developed application to Azure. The architecture requires the application to run across 10 Azure virtual machines. To maintain service-level agreements, you must guarantee that at least 8 of these virtual machines remain operational during any planned Azure platform maintenance event. What is the minimum number of update domains you should configure in an availability set to meet this requirement? Focus on the distinction between these options. Now examine choice A. Deploy the instances into an availability set configured with 10 update domains. Now examine choice B. Deploy the instances into a virtual machine scale set with 12 instances. Now examine choice C. Deploy the instances into an availability set configured with 5 update domains. Now examine choice D. Deploy the instances into an availability set configured with 3 fault domains. The correct answer is option C. Deploy the instances into an availability set configured with 5 update domains. The key reason is Azure updates 1 update domain at a time during planned maintenance. Distributing 10 virtual machines across 5 update domains places at most 2 virtual machines in each domain, so at least 8 remain running. Fewer than 5 update domains could place more than 2 virtual machines in one domain. The alternatives can be eliminated because A. 10 update domains would also preserve at least 8 virtual machines, but it is not the minimum number requested. B. Deploying 12 instances increases costs and does not answer how they are protected during maintenance if they aren't distributed properly. D. Fault domains protect against unplanned hardware failures, rack/power/network, not planned maintenance. Keep this examination point in mind. Update domains protect against planned maintenance, fault domains protect against hardware or rack failures. Review question number 188. Carefully. Next, we enter the topic of VM resource moves. Review the scenario carefully. You deploy an Azure virtual machine named WebProd01 into a resource group named RGWeb. You receive a platform alert stating that the underlying hardware hosting WebProd01 is degraded and scheduled for emergency maintenance. You must immediately shift the virtual machine to a healthy physical host node. You navigate to the overview blade of WebProd01 in the Azure portal and move the virtual machine to a different Azure subscription. Does this meet the goal? Compare the following options. Choice A, yes. Choice B, no. The required response is option B, no. Moving a virtual machine to a different subscription is a logical management boundary change, not a physical compute change. It does not force the virtual machine to migrate to a new physical host node. To immediately move the virtual machine to a healthy host, you should use the redeploy feature. The remaining options are incorrect because A. This solution is incorrect because shifting the logical subscription assignment does not address the underlying hardware issue or force a host migration. A useful examination rule is this. Use the redeploy feature to move an Azure VM to a new physical host node when experiencing hardware or host-level connectivity issues. Now consider question number 189. Consider this scenario. Your organization has an Azure virtual network named VNet Core. You configure a point-to-site (P2S) VPN connection using Azure Certificate Authentication with a self-signed root certificate. You successfully connect to the VPN from laptop 1. You now need to connect from a newly provisioned device, laptop 2. You download and install the VPN client configuration package onto laptop 2. You modify the conditional access policies in Microsoft Entra ID to grant laptop 2 access. Does this meet the goal? Option A. Yes. Option B. No. The best answer is option B, no. This is correct because the point-to-site VPN is configured to use Azure Certificate Authentication, using a self-signed root certificate. Each connecting client must have a valid client certificate installed in its local certificate store. Modifying Entra ID policies does not deploy the required client certificate to laptop 2. The incorrect choices fail for the following reasons. A. This solution is incorrect because Entra ID policies only affect Microsoft Entra Authentication, not Azure Certificate-based authentication. The key takeaway is when using Azure Certificate Authentication for P2S VPNs, every client device must generate and install a valid client certificate derived from the trusted root certificate. Let us examine question number 190. We are moving to VM resource moves. Begin by examining the scenario. You deploy an Azure virtual machine named DB-Node using an Azure Resource Manager, ARM, template. Azure Health Service notifies you that DB-Node is hosted on a physical server scheduled for emergency hardware replacement. You must move the virtual machine to a different physical host immediately to prevent unexpected downtime. You navigate to the Redeploy plus Reapply blade of the virtual machine in the Azure portal and click Redeploy. Does this meet the goal? Review each available choice. Option A is yes. Option B is no. The appropriate choice is option A. Yes. Here is the technical justification. The redeploy action gracefully shuts down the virtual machine, moves it to a new Azure Compute node, physical host, within the same region, and powers it back on. This directly resolves issues related to degraded underlying hardware. Now consider why the remaining options are unsuitable. B. The proposed solution accurately accomplishes the goal, so no is incorrect. Redeploying an Azure virtual machine is the primary method for moving a VM to a different underlying host node to resolve physical hardware or host agent issues. The next item is question number 191. Review the situation. Your organization uses Microsoft Entra ID. The tenant's maximum number of devices setting is configured to 3 devices per user. An employee named user_dev1 has already joined or registered 3 devices and is now trying to register a new smartphone. The registration fails. You need to ensure that user_dev1 can register the smartphone. What should you do? Review the options. Choice A. Assign the cloud device administrator role to user_dev1. Choice B. Instruct user_dev1 to connect to the corporate network by using a point-to-site VPN. Choice C. Modify the users may register their devices with Microsoft Entra ID setting. Choice D. Increase the maximum number of devices setting or remove one of user_dev1's existing device registrations. In this case, select option D. Increase the maximum number of devices setting or remove one of user_dev1's existing device registrations. The requirement is satisfied because user_dev1 has reached the tenant-configured device limit of 3. A user who reaches this limit cannot join or register another device until the limit is increased or an existing device registration is removed. A. An administrative role does not bypass the per-user device limit and violates least privilege. B. Microsoft Entra device registration occurs over the Internet and does not require a corporate VPN. C. The failure is caused by the device quota, not by the tenant-wide registration permission. Exam tip. When one user cannot add another Microsoft Entra joined or registered device, compare the user's existing device count with the maximum number of devices setting. Review question number 192. Carefully. Next, we enter the topic of Azure RBAC. Review the scenario carefully. You manage an Azure subscription named subprod that is associated with your organization's Microsoft Entra ID tenant. The tenant contains a security group named Integration Team. Subprod contains a resource group named RG Logic. You need to allow the Integration Team group to create and manage Azure Logic apps strictly within the RG Logic resource group. You assign the Logic App Contributor role to the Integration Team group at the subscription scope. Does this meet the goal? Now examine the possible answers. Option A is yes. Option B is no. The best answer is option B, no. The reasoning is as follows. While the Logic App Contributor role grants the correct permissions, assigning it at the subscription scope violates the requirement to allow management strictly within the RG Logic resource group. The assignment would grant the team access to create Logic apps across the entire subscription. The role should be assigned at the resource group scope. The other choices do not satisfy the requirement because A, this solution is incorrect because it applies the role at too broad a scope, providing access outside of the required boundary. Remember this distinction for the exam. Always apply Azure RBAC roles at the narrowest scope possible, such as a resource group or specific resource, to maintain least privilege. Proceed to question number 193. Scenario. Your organization uses an Azure Management Group hierarchy configured as follows. Tenant Root Group is the top-level parent. MG Corp is a child of the Tenant Root Group. MG Dev is a child of the Tenant Root Group. MG Sandbox is a child of MG Corp. You have 2 Azure subscriptions deployed. Sub A is assigned to MG Sandbox. Sub B is assigned to MG Dev. You have the permissions required to move subscriptions between management groups. You apply 2 Azure policy assignments. At Tenant Root Group, you assign a policy using the built-in Not Allowed Resource Types definition with the parameter set to Microsoft Network/Virtual Networks. At MG Dev, you assign a policy using the built-in Allowed Resource Types definition with the parameter set to Microsoft Network/Virtual Networks. For each statement, select Yes if the statement is true. Otherwise, select No. Review Statement 1, you can deploy a virtual network in Sub A. Review Statement 2, you can deploy a virtual machine in Sub B. Review Statement 3, you can move Sub A from MG Sandbox to MG Corp. The answer to Statement 1 is no. The tenant root policy denies the creation of virtual networks across all descendant scopes. The answer to Statement 2 is no. The policy on MG Dev only allows virtual networks. Any resource type not in the allowed list is denied. The answer to Statement 3 is yes. Policy assignments restricting resource creation do not prevent moving a subscription within the management hierarchy. Keep this examination point in mind. The allowed resource types built-in policy acts as an explicit allow list. Any resource type not defined in the policy parameter is automatically denied. Deny policies at higher scopes cannot be overridden by allow policies at lower scopes. Question number 194. You manage 2 Azure subscriptions, subprod 01 and subprod 02, that are associated with the same Microsoft Entra tenant. Subprod 01 contains the following resources: AppVM, an Azure Virtual Machine. AppVM_OS disk, the managed disk attached to AppVM. AppVNet, an unpeered virtual network that is not used by AppVM or any other resource. AppStorage, a standard storage account with no dependent resources. VaultASR, a recovery services vault configured with Azure Site Recovery and actively replicating AppVM to a secondary region. You need to identify which resources can be moved directly to subprod 02 without first disabling an existing configuration. Which resources should you identify? Available choices. Option A, AppVM, AppVM_OS disk, AppVNet, AppStorage, and VaultASR. Option B, VaultASR only. Option C, AppVM and AppVM_OS disk only. Option D, AppVNet and AppStorage only. The correct answer is option D, AppVNet and AppStorage only. The key reason is App VNet and App Storage have no dependencies that block a cross-subscription move, and both subscriptions use the same Microsoft Entra tenant. App VM and its disk cannot be moved while Azure Site Recovery Replication is active, and the actively used Recovery Services Vault cannot be moved directly. The alternatives can be eliminated because A, the actively replicated VM, its disk, and the Site Recovery Vault require the replication configuration to be removed first. B, an actively used Site Recovery Vault cannot be moved directly. C, App VM and App VM_OS disk cannot be moved while replication is enabled. A useful examination rule is this. Before moving an Azure VM protected by Site Recovery, disable replication, complete the resource move, and then configure protection again. Now consider question number 195. Scenario. You manage an on-premises DNS server that hosts a primary DNS zone named fabricam.com. The zone contains over 1,500 DNS records. You need to migrate the fabricam.com zone to an Azure DNS zone. The solution must minimize custom scripting and administrative effort. Which tool should you use? The options are: Choice A, the Azure Portal. Choice B, Azure CLI. Choice C, the DNS Manager console. Choice D, Azure PowerShell. The required response is option B, Azure CLI. Azure CLI includes a native command, AZ Network DNS Zone Import, specifically designed to import a standard bind zone file directly into Azure DNS. This minimizes administrative effort because it handles the creation of all 1,500 records automatically without requiring custom scripting. The remaining options are incorrect because A, the Azure portal does not have a bulk import feature for DNS zone files. Records would have to be created manually. C, the on-premises DNS Manager console cannot directly export and sync to an Azure DNS zone. D, Azure PowerShell does not have a native, single command to import a zone file. You would have to write a complex script parsing the file and calling new AZ-DNS record set iteratively. The key takeaway is to migrate a large DNS zone file to Azure DNS with the least administrative effort. Export the zone file from the source server and use the AZ Network DNS Zone Import Azure CLI command. Proceed to question number 196. This is a medium-level challenge. Consider this scenario. You have an Azure virtual network that contains a multi-tier internal application named App1. App1 is an HTTP/HTTPS application hosted on a backend pool of 4 Windows Server virtual machines. Remote employees access the virtual network from home using a point-to-site (P2S) VPN. Branch office users access the virtual network using a site-to-site (S2S) VPN. You must implement a solution to distribute incoming private IP traffic evenly across the 4 virtual machines hosting App1. Which 2 Azure services can you use? Select 2 answers that satisfy the requirement. Review the options. Option A, Azure Front Door. Option B, an internal Azure load balancer. Option C, an Azure Application Gateway. Option D, Azure Traffic Manager. Option E, a public Azure load balancer. The correct answers are option B, an internal Azure load balancer, and option C, an Azure Application Gateway. This is correct because the traffic is originating from users on private VPN connections. The traffic is internal to the virtual network. To balance this traffic, you need a load balancing solution that accepts traffic on a private IP address. An internal Azure load balancer operates at layer 4 and uses a private front-end IP address. An Azure Application Gateway operates at layer 7 and can use an internal private front-end IP address to distribute the stated HTTP/HTTPS traffic. The incorrect choices fail for the following reasons. A. Azure Front Door is a global service that requires public-facing endpoints. It cannot balance traffic strictly on a private virtual network. D. Azure Traffic Manager is a DNS-based traffic router designed for global distribution, primarily routing traffic to public endpoints. though it supports private endpoints, it does not act as a traditional internal data plane load balancer. A public Azure load balancer uses a public front-end IP address, which does not align with distributing private internal VPN traffic. Use an internal Azure load balancer, Layer 4, or an Azure application gateway with an internal front-end, Layer 7, to distribute private, non-internet traffic within an Azure virtual network. The next item is question number 197. You plan to deploy a line of business application across two Azure virtual machines named SRV Web 01 and SRV Web 02. You intend to place both virtual machines into an Azure availability set. You need to ensure that the application remains available when Azure performs routine planned hardware updates on the underlying host nodes. What must be configured within the availability set to meet this requirement? Choice A. 2 update domains. Choice B. 1 update domain. Choice C. 1 fault domain. Choice D. 2 fault domains. The correct answer is option A. 2 update domains. Here is the technical justification. Update domains dictate how virtual machines are grouped for planned maintenance. When Azure patches underlying hosts, it reboots 1 update domain at a time. By configuring the availability set with at least 2 update domains, you ensure that the 2 virtual machines are placed in different domains, meaning they will not be rebooted simultaneously during planned maintenance. Now consider why the remaining options are unsuitable. B. If both virtual machines were in a single update domain, they would be rebooted simultaneously during host patching, causing downtime. C and D. Fault domains protect against unplanned hardware failures, like a rack losing power or network switch failure, not scheduled planned maintenance updates. Exam tip. Update domains protect against downtime from planned maintenance. Fault domains protect against downtime from unplanned rack or server failures. Let us work through question number 198. This question moves us into Azure policy. Consider the following scenario. An administrator creates an Azure policy assignment with the following configuration: scope, subscription marketing exclusions, subscription marketing/RG dev environment policy definition, not allowed resource types parameters, Microsoft, compute/virtual machines. What is the operational effect of this policy? Review each available choice. Choice A, you can create virtual machines anywhere within subscription marketing except in the RG dev environment resource group. Choice B, you are completely prevented from creating virtual machines anywhere in subscription marketing, including RG dev environment. Choice C, you can only create virtual machines within the RG dev environment resource group. Choice D, you can create virtual machines in any resource group within subscription marketing without restrictions. The appropriate choice is option C. You can only create virtual machines within the RG dev environment resource group. The requirement is satisfied because the policy is assigned at the subscription scope and denies the creation of the specified resource type, virtual machines. Because RG dev environment is explicitly added as an exclusion to the assignment, the deny policy does not apply there. Consequently, virtual machines are blocked everywhere in the subscription except inside RG dev environment. A. This describes the exact opposite of the configuration. The exclusion allows the resource in that specific RG, while the policy denies it everywhere else. B. This ignores the exclusion. An exclusion explicitly exempts a lower scope from the policy assignment. D. This ignores the policy assignment completely. Virtual machines are explicitly denied at the subscription scope. Remember this distinction for the exam. When evaluating Azure policy, remember that assignments apply to the scope and all its descendants. Adding an exclusion exempts that specific child scope, and its descendants, from the policy's effects. Question number 199. Review the situation. Your organization is migrating 50 terabytes of archive data from an on-premises data center to Azure Blob Storage. Because of bandwidth limitations, you plan to use the Azure Import-Export service. Before preparing and encrypting the physical hard drives by using WE Import Export version 1, you must create the required configuration files. Which two files must you create? Select exactly two answers. The options are: Option A, a JSON configuration file. Option B, a dataset CSV file. Option C, a PowerShell PS1 script. Option D, a DriveSet CSV file. Option E, an XML manifest file. The required selections are Option B, a dataset CSV file, and Option D, a DriveSet CSV file. The reasoning is as follows. When using WA Import Export version 1 to prepare drives for an Azure Blob Storage import job, the tool requires two comma-separated value files, the dataset.csv file, which specifies which directories and files from the on-premises server will be copied to the drives. The driveset.csv file, which maps the physical drive letters to the drives being prepared. The other choices do not satisfy the requirement because a JSON file is not used by the WA Import Export tool to define the job configuration. C, a PowerShell script is not required to prepare the drives, as the WA Import Export command line executable handles the encryption and copying. E, while the tool generates a journal file, often XML/binary, you do not manually create an XML manifest file prior to running the tool. Keep this examination point in mind. WA Import Export version 1 uses dataset.csv to define source data and driveset.csv to define the target disks before drive preparation. Next, question number 201. You manage an Azure virtual network named VNetHQ. VNetHQ is currently connected to your on-premises data center using an Azure Express Route circuit. The virtual network uses an active gateway subnet. To improve high availability, you need to configure a site-to-site (S2S) VPN as an automatic failover path if the ExpressRoute connection fails. You must minimize ongoing infrastructure costs. Which three resources must you create to implement the VPN fallback? You need to identify three correct options. Choices. Option A, a VPN gateway that uses the basic SKU. Option B, a local network gateway. Option C, a connection. Option D, a new gateway subnet. A VPN gateway that uses the VPN GW1 SKU. The choices that satisfy the requirement are Option B, a local network gateway, Option C, a connection, and Option E, a VPN gateway that uses the VPN GW1 SKU. The key reason is to establish a site-to-site VPN alongside an ExpressRoute connection. ExpressRoute and VPN coexistence. You need a local network gateway. This defines the on-premises VPN device's IP address and address spaces. A virtual network gateway, VPN. This must be created on the existing gateway subnet. However, coexistence is only supported on specific SKUs, the basic SKU is not supported. Therefore, you must use VPN GW1 or higher. A connection, this links the Azure VPN gateway to the local network gateway using IPsec. The alternatives can be eliminated because a, the basic SKU for VPN gateways does not support coexistence with ExpressRoute. D, a virtual network can only have one gateway subnet. Because ExpressRoute is already connected to the VNet, the gateway subnet already exists. You cannot create a second one. A useful examination rule is this. When configuring VPN and ExpressRoute coexistence on the same VNet, both gateways deploy into the same gateway subnet. The VPN gateway must be a route-based gateway using the VPN GW1 SKU, or higher. You have completed Part 5 of the AZ-104 Microsoft Azure Administrator Exam Practice Series. Keep building your Azure administration skills by opening the complete playlist and continuing with the remaining parts in sequence. If this session helped your preparation, like the video, subscribe to Tech with Kaushik, and enable notifications for more certification exam practice content. Share your score, doubts, or feedback in the comments. I would be happy to hear how your preparation is going. Thank you for learning with Tech with Kaushik. Keep practicing, and I will see you in the next part.